right, the third section in our lessons covers questions 5, 6, and 7. Sometimes machine diagrams are used to represent functions. In the function machine below, the inputs are labeled X and the outputs are labeled Y. The function is represented by the expression 2x plus 5. And notice we have it inputting X. We do this function or these operations, and my output is Y. What is the output if the input is X equals 7, X equals negative 2, and X equals 1/2? And we're putting it into this function. So if 7 goes in, 2 times 7 plus 5, well, the first operation that happens is the 2 times 7. That's going to be 14 plus 5 is 19. So we input 7, our operations happen, and then we output 19. Okay, what happens if negative 2 goes in the machine? So 2 times negative 2 plus 5. Well, the first thing that happens is the multiplication, so that's negative 4, and negative 4 plus 5 is a positive 1. Lastly, what happens if we input 1/2? What would our output be? So 2 times 1/2 is 1. 1 plus 5 is 6. So we input 7, we get 19. We input negative 2, we get 1. We input 1/2, we get 6. B, express regularity and repeated reasoning. Is there any limit to the number of input values that can be used with this expression? And explain. Are we limited by the x values? Is there any x value I can plug in or that I cannot plug in? Exactly. There is no limit to the number or type, it should be or type of input values. Now recall, earlier we couldn't put in like decimals. Here I can put in a decimal because it's represented by an expression. So no limit. Number 6, consider the function machine below. Use a diagram to find the input-output or the ordered pair for the following values. So we're looking for an ordered pair. So remember, it's always x comma y. So this would be negative 5 comma something. This would be 3/5 comma some unknown. And this would be negative 10 comma something. Now, I'm going to save time purposes here. I'm going to use a calculator. All right. So I'm going to put my screen so you can see it. I'm going to start with negative 5. And because I want the negative to be squared, I'm going to put both of them in parentheses. And I'm going to square that. And then we add 2 times negative 5. And then we add 3. So my output is 18. Well, that makes sense because negative 5 squared plus 2 times negative 5 plus 3. This is going to be 25 minus 10 plus 3. So that's 15 plus 3 is indeed 18. All right. So now we're going to take 3 over 5 squared plus 2 times 3 over 5 plus 3. 4.56. Let's take a look at that. Here we've got 3/5 squared plus 2 times 3/5 plus 3. Well, remember that when we square this, we square top and bottom, so that would be 9/25. Here we would just multiply the 2 times the 3, so this would be plus 6/5, and this would be plus 3. Now, in order to add, remember that we have to have common denominators, so we need everything to be over 25. So I'm going to make this over 25. If I put this as a denominator of 25, that means my numerator is going to be 30 because I would have multiplied 5 here and 5 here. And then here, this would be 75 over 25. So let's just do a quick check. We're going to do 9 plus 30 plus 75. Gives me 114. All over 25, right? Well, I'm hoping that when I divide by the 25, it gives me what I had earlier. So you could have written this 2 ways. I probably would have written it this way, 3/5, comma, 4 and 14/25, because I don't like to do one as a fraction and the other as a decimal. I don't like to mix those. So I would have either wanted them both as decimals or both as fractions. The reason I didn't use the 114 over 25, because if I actually try to go to plot that, 114 over 25 is not going to be anywhere like I can estimate to. So that's the reason why I put it as a mixed number with the 4 and 14 over 25. Now let's look at C. C says we're going to put in negative 10. So I got negative 10 squared plus 2 times negative 10 plus 3. Well, negative 10 times negative 10 is 100. And 2 times negative 10 is negative 20 plus 3. 100 minus 20 is 80. 80 plus 3 is 83. I'm going to use my calculator just to double check my math. So I got negative 10 to the second power plus 2 times negative 10 plus 3. Gives me a value of 83. So now I've listed these as ordered pairs, but I started out with an expression. Let's move to question 7. Question 7 says, make a function machine for the expression 10 minus 5x. Use it to find ordered pairs for x equals 3, x equals negative 6, x equals 0.25, and x equals 3/4. So input my x. We're going to put 10 minus 5x, and my output is my y. All right, so again, we're going to do 3. So 10 minus 5 times 3. So that's 10 minus 15, and that's going to be negative 5. Let's do negative 6. 10 minus 5 times negative 6. Well, negative 5 times negative 6 is positive 30. So 10 plus 30 is 40. We're going to do 0.25. 10 minus 5 times 0.25. Well, 5 times 0.25 is going to be 1.25. And 10 minus 1.25 is going to be 8.75. Next, we're going to do 3/4. So we're going to input 3/4. So we've got 10 minus 5 times 3/4. Well, 3/4 of negative 5 is going to be negative 3.75. And so we're going to do 10 minus 3.75 is 6.25, but I don't like that because, see, again, we've mixed this decimal fraction combination, right? So I would write this as 3/4, comma, 6 and 1/4. On to your debriefing.